In this video, we are going to discuss about current shunt negative feedback. So this is also called as shunt series. So since in the input you have shunt, that is current, output also current, this is also called as current amplifiers. So I can draw on the output shunt, sorry, at the input shunt and output is current, so I have drawn it in series. So input also current and output also current. So input I have represented as Is and output I have represented as I0. So here the I0 is in this direction, opposite direction, IL is in towards right side. So I can write AI is equal to output current divided by input current II, where beta is equal to output is IF, input is I0. So in order to find the input resistance, we are going to replace this current shunt feedback by its Norton model. So here Is, we are having Is, so the resistance should be in parallel, and this is Ri. So the current If should be flow towards downwards, that is If is equal to beta I0, and this is AI. AI is equal to, since AI is equal to I0 divided by IA, so I can write this should be in always in upper direction. A should be in parallel with R0, and this is your RL. Okay. So I need to find the value of RIF. So I can write IS. What is your IS? IS is equal to IA plus IF, because this is your incoming current and this 2 is your outgoing current. So I can write Is is equal to IA plus IF. IF I can write it as beta into I0. So what is I0 here? So I0 is nothing but I0 is this current. I0 is equal to I0 is equal to AA IA into R0 divided by R0 plus RL. So I0 is the current that is flowing towards this direction. So I0 is equal to AI into R0 divided by R0 plus this resistance. So this resistance is nothing but RL. Okay. So I am going to substitute this value here. Okay. So I can take this whole term AI divided by R0 plus RL is equal to A capital I. So I can write I0 is equal to AI II. So you substitute the second equation in the first equation. So you will get Is is equal to IA plus beta AI into IA. So if you take IA common, you will get 1 plus beta AI. So what is you have to divide the whole term by VI, right? So if I divide VI IS whole term by VI, I will get IS by VI and IA by VI. What is IA by VA? IA by VA is 1 divided by RI, and this one is 1 divided by RIF. So I can write RIF is equal to RI divided by 1 plus beta AI. So you can see, since we are using a shunt connection at the input resistance is decreased by the factor of 1 plus beta AI. Next we need to find the output resistance. So in order to find the output resistance, you have to disconnect the circuit, right? So so the RL goes to infinity and the external source, that is your IS, should be 0. Therefore you have to connect it, you have to open circuit that one, right? You have to short circuit that one, and sorry, you have to open circuit that one. So I can write here I. What is I? Okay, so if you see this circuit, this is your I. So I can write this I is equal to this voltage divided by R naught minus AAIA, right? So I is equal to V divided by R naught minus AAIA. So we know that what is IF? IF is equal to beta I naught, but here I am using I only. So IF is equal to beta I. Okay, so instead of IA, you have to substitute. Since we have taken this IS is equal to 0, IS is equal to 0, IS is equal to 0, I can write IA is equal to minus IF. Okay, so you substitute here. You substitute here, so you will get I is equal to V divided by R naught plus A into IF. Okay, so this IF I can substitute as beta I. So this becomes minus. So I is equal to V divided by R naught minus beta AAI. Okay, so you take this whole term to the right, left hand side, you will get I plus beta A I is equal to V divided by R naught. So you take the common I term, so V by I is nothing but your R naught F. So R naught F is equal to R naught into 1 plus beta A. So since the output we are giving a series connection, the input output resistance is increasing. So we know that R naught dash of F is equal to R naught F in parallel with RL. Since we have taken the circuit common, R naught F we have already calculated. So R naught dash F is equal to R naught F in parallel with this RL. So so this is the value. You substitute R naught F from this equation. So you substitute this value. So if you substitute, you will get R naught F dash is equal to R naught RL divide into 1 plus beta AA divided by R naught plus RL plus beta AA R naught. So you take R naught, you divide the whole term by R naught by RL. So if you divide the whole term by R naught by RL, this will cancel out. You will get 1 plus beta AA R naught divided by R naught plus RL. So this whole term I can write it as R naught dash. So R naught dash 1 plus beta AA divided by 1 plus beta. This whole term is nothing but A capital I. Okay. So we have calculated the value of voltage gain, then input resistance and output resistance. So I hope this video is useful for you. Thank you very much.